Again, if you are a member of our organization, you received your membership renewal form either today, maybe tomorrow, and that's really the lifeblood of what we do. So if you're able to support us, we appreciate that. If you're not a member and you would like to become a member, we do have membership forms up here. You can feel free to take one or take another one to pass it along to a friend or a relative. We also have some interesting postcards and note cards and other little treasures from the Historical Society that you can feel free to browse through when the program's over. And I would like to introduce Justin Emershaw, our speaker for the evening. Justin is a mining engineer with Atlantic Carbon, which is Hazleton based, correct?
Yeah.
And also the son of our board member, Sherry.
Kudos to mom, there she is. Well, thank you, everyone. Thanks for coming out tonight. So, as Mary mentioned, so my name's Justin Emershaw. I'm mine engineer with Atlantic Carbon Group in Hazleton. So, how many in here have an idea that coal is still mined in Pennsylvania today? Okay, so, all right. So, it's not going to take anybody as a surprise then that nobody knows that we haven't touched coal around here in 30, 40, 50 years. So that's cool. So what I'm going to pretty much be going through today is kind of a glimpse of how we actually mine anthracite today. Part of all of which is pretty much my job. And it kind of gives you an idea of just how different it is from the 1960s, 1900s turn of century, and just some of the mechanics that go into making it safe and efficient mining. So where is Pennsylvania anthracite? We probably all know this, right? But thank you. So probably what some people don't know is that there's a couple different anthracite fields. You have the northern anthracite field. Eastern Middle is where the firm I work for, Atlantic Carbon, is based. We're based right out of Hazleton. We primarily dominate and operate the Eastern Middle field. And then you can go down further south, you get into the Western Middle field, which would be everything Monoy City all the way out to Shamokin. And then the southern field would run from Nesquehoning all the way down to Tower City. The interesting thing is, even though we have all this anthracite, about 32 billion remaining tons, every field is a different quality. And that becomes huge when you're looking at sales and just marketing of the coal. So Eastern Middle around Hazleton is actually more classified as a meta-anthracite. It's the highest grade anthracite in Northeast Pennsylvania. The carbon content rate on average starts at about 90% and can range up to about 95%. 100% pure carbon would be diamonds. So we're almost there.
I'm still looking.
So here's kind of a better zoom in of like what it was originally called the Lehigh coal field. It's broken up, the Eastern Middle field, into a couple separate basins. You have the Green Mountain Basin. We operate primarily in the Hazleton and the Black Creek basins. We also have operations down in the Beaver Meadow Basin, which is right on the border of Carbon County. So the first thing as a mine engineer, my job really is, we got all these coal reserves all over the place. We know it's there because it's been mined since the 1800s. So it's well mapped, it's well documented. But the first thing is that I look at whenever we're looking at a new property or expanding reserves is, how do you take a resource and turn it into a reserve? So a resource is defined as anything that exists under the ground that can be commercially marketed. Oil is a resource. Coal is a resource. But what makes a reserve, which is what I look for, is what's economically feasible of that resource to mine. You might have coal that's down a mile underground. It's a resource. You'll never be able to physically extract it because it's too deep. So the reserve part is looking at what makes sense to mine based on today's market conditions, based on the cost of the operational costs of the operation. And this is pretty much my job, is to determine the percent coal remaining, which we'll go through a little bit of that. And then, how much of the reserves on the property is mineable. And that determines what's called a stripping ratio. Stripping ratio is very important for a mining company today, and that's where you're looking at how much rock, or we call it overburden, has to be excavated off to expose the coal seam. Normally on today's market conditions, you don't want to go over about 15 to 1. You might hear me throughout the presentation talk about like 10 to 1, 5 to 1. That means 5 cubic yards of rock, or 15 cubic yards of rock for every 1 ton of coal extracted. First, back up here. The first thing that we do, which is really cool, some of you might be familiar with the old geologic mind maps. We still use these today, and these are they are the only source of information that we have today, and the most accurate information about what actually went on subsurface mining, and give a good indication of just the geology and the coal formations. So the cool thing is, a few years ago at work, we had a firm come in, and they wanted more accurate, they were interested in more accurate ways of modeling anthracite. And the firm was very familiar with oil and gas. And in oil and gas, they use what's called seismic analysis. And they actually use these big machines that put vibrations through the ground. And then the seismic waves actually resonate differently off different types of rock stratas and everything. And it gives very good indications for like Marcellus shale or oil. Well, they were very keen on trying to use this in anthracite. The problem is it doesn't work. In fact, there's no modern technology that really works to map more accurately what's still underground than what they did 100 years ago, because everything has been previously deep mined. When they deep mined it, they left numerous void spaces. That's what affects the seismic technology that this company was looking at. If you have void spaces, you're not going to get any resignation. So here we are, 100 years after they started, or better, after they started deep mining anthracite, and we're still using mine maps that these guys drew over 100 years ago. The accuracy of these is, from my experience, really incredible. We've had instances on our operations where we'll be excavating a block of coal out. We'll hit the mine tunnels, we always call them, where you could see the miners came through like the rock and took the coal out. If you survey, and we have, those tunnels and then overlay them, we use AutoCAD for all of our mapping. If you bring the mine map underneath the surface where you can see those tunnels, they line up almost perfectly. It's really amazing how accurate these guys were 100 years ago with mapping. So to kind of give you an idea, this is what's called a cross-section map, and because I work down by Hazleton, this is a cool map to kind of show if you were to take a big knife and kind of cut right through the city like a loaf of bread and just split it open. This is what you'd see. So every one of these horizontal lines that you see, those are 100-foot grid lines determining changes in elevation. So every one of these lines reflects 100 feet vertically. So if you were to count them, you could see you're down over 1,200 feet in depth here. This is the Mammoth coal seam here, this big looking one, which is the primary seam that we mine today because it's the thickest. It was the first coal seam mined pretty much on all the coal fields, whether it be Southern. I think they called it a different name up here. I think it might have been called the Big Bed. But it's the Northern field guys had to have different names. That's another cool thing. So all these coal names, every anthracite region had their own names, or they could have been slightly different from another region. So like, for example, Mammoth was Mammoth Bed, but up north they call it the Big Bed. The vein right behind the Mammoth that's lower, which is called the Wharton, which was actually named after the president of the Beaver Meadow Railroad, Mr. Wharton. He was also the founder of Wharton University. Down south, if you go down by, in the southern field, down by Tamaqua, all the way to Tower City, it's called the Skidmore vein. So the names are always different. And then there's some collieries that actually numbered their coal seams, which is even more confusing. But that's kind of a good overview. So what I do, the first step to model coal today, if we were going to look at a property to mine, whether it's maybe somewhere in the north here or down by Hazleton, is to take all these cross sections and we bring them into AutoCAD. And when we bring them in, they're aligned off of a center line, and then all the coal seams are traced. We trace them with what are called two-dimensional lines, and then those two-dimensional lines will turn into three-dimensional to actually make what's called a geologic model. So remember this cross section. So this is a project. This is actually I didn't put these particular slides together just for this presentation. These actually came from a project I was working on last summer, and this was a section of our Jetto mine site that we're going to be starting up probably next year. We're naming the site Highland Mines, but this is a section showing a couple coal seams that were identified as the Gamma. Then we have two splits of the Buck Mountain seam. And when I look at these, so you're probably wondering, well, how do I know that this is something I want to mine? Well, visually, from years of looking at this, if this is the surface here, look how close this coal seam comes to the surface. And then this one, and the horizontal lines are showing right here, this is 100 feet. But within that 100 feet, I have the Buck seam, which is about 10 foot, and the Gamma seam, which is about 4 foot. So 14 foot of coal under 100 foot of cover is a pretty reasonable mining ratio, provided the coal's still there, which is the next part. So all the coal seams are then taken, and you can kind of see they look like a bunch of lines. So this is taking every one of them sections. If I took the cross sections away, you'd see all this individual line work. It's just spun on an angle here. And then that same cross section that I just showed you, now you can see it kind of getting turned into 3D. So you can see every one of those seams. Remember that shape, right? That roll. There they are as three-dimensional. And the surface model that we use here, we use LiDAR topography, and we'll overlay that over the coal seams. And now we've effectively created what's called a geologic model. So we have a modern day surface, and we've mapped all of our coal seams underground. This essentially allows you to do volumetric calculations and designing a open pit mine. But before we can do that, next step 5, you need to, and this is where engineering will look at mine maps. Call it engineering because in a bigger firm there'd be multiple engineers, but as of right now I'm one of 2, or second engineer who just came out of college, just started with us 2 months ago. So for 10 years with the firm, engineering has been me. So, but anyway, so when we overlay the mine maps in AutoCAD, you can kind of see this map here is an overlay of the Buck Mountain coal seam, which averages about 10 foot thick. These are all the coal pillars, and you'll see this anywhere a lot. If you see pictures of mine workings, you always see the pillars. We hear all about the pillars. This is them, and if they're hatched, where they draw little lines through them, that means they came back a second or third time in the mining process and did what was called, who knows? Robbing. I like that. Everybody knows that one. So this is where it really, in order to make an accurate calculation of just how much coal is there, there's no way to possibly do it, because you don't know what they took. They just marked it that they robbed it, but we don't know if they took 30% more coal, 20, 50. So the next step of the process is, I'm just a nerd. I like this part of the process. This is test drilling, okay? So the reason why this is cool to me is because now I'm taking elevations on those mine maps, and I'm going out to our crew that brings in the big rotary blast drills, and they're going to drill down to the elevations that I tell them to. So it could be 200 feet, it could be 300 feet, but the drillers are relying on me and saying, how far down till I hit the first coal seam? And I might say, well, you got probably about 320 feet. And on this one right here, if you look, we hit coal. So this is what's called the driller's log. So as they're drilling, and this is one of the most important things when we're rotary test drilling, having a really experienced driller is key. And these are guys that have been in the seat, like with any piece of heavy equipment or anything you do, carpentry, plumbing. You do it a long time, you get to know it. The tools become an extension of you. So these guys can tell me, as they're drilling, what kind of different rock they're in, if they hit clay, if they hit voids, and they definitely know when they hit coal, because you start seeing black pieces of coal coming up the drill pipe. But for example here, so I was thinking we should be around 300 feet with the first coal seam. Here we are hitting the mammoth seam at 311 feet. And then at 311 to 313 feet, we have rock divider. And then below that, from 313 all the way up to 317, we're back into coal. So this is to verify that the coal is still there. And it actually gives you a good representation of also the seam thickness. Because when we build the coal veins in AutoCAD, I'm assuming a thickness. The test drilling confirms exactly how thick it is because they puncture right through there.
Are they core drills?
So core drilling is a little bit different, and core drilling is the benefit to core drilling over rotary air drilling is you actually can physically pull up a core sample of the coal, where rotary you can't. It just sprays it up. You know what's there, but with coring you get a sample that then you could send out for a chemical analysis. So these are all rotary test drilling results, and I kind of put them in Excel format here. Everything in green that I highlighted is the Buck Mountain seam, and I labeled the thickness. So for example, right here, this is the driller's log converted into Excel to show, like, I had 65 foot of fill, then we had 25 foot of hard rock, so on and so forth, and all the coal seams are logged. So from this information, I can then look over here. I kind of put a summary table together to say, out of all the drill holes that we put down, I can take an average and say that gamma seam is 3.3 foot thick. It's not 4 like I thought. And the buck seam, it averaged 9.3 feet. So this gives me that extra level of accuracy to really make educated assumptions on how much coal is still remaining underground. And then if the volumetric calculations look right, so if I say there's 30% of this coal seam remaining, and you kind of judge that by how many holes you hit coal in. So if you don't hit coal in any holes, it's a real bad day. But if it looks good, so the next process is designing a open pit mine. So it's very different today than it was, 50 years, even 100 years ago. Mines are heavily regulated. You're going to see it's probably one of the most heavily regulated industries. We have a lot of criteria to follow from what's called a ground control plan, which is enforced by Mine Safety and Health, or Emershaw. They want to see a plan to say, okay, you're going to mine down in this view here. This is a pit shell, I like to call it, that I designed to go down 330 feet. You can see the green access road. All these blue lines are benches and what a bench is, it's part of a ground control plan. It basically says that every so far down you dig, you have to step out and leave what's called a bench. So that's so that any rocks don't roll down. It makes it safe as you're excavating down really deep. Because you don't want things like this to happen. And this happened actually out in Bingham Canyon in Utah. So here you can see that this is a big open pit gold mine, gold and copper. You can see the haul road go down. The whole side of the high wall just failed and came down. So that's the whole purpose of doing engineering and actually properly designing a mine today. So before we can get into actually mining, one thing I want to mention, this is one of the most expensive industries that you will ever get in. Mining is, as I mentioned, heavily regulated. It's not like we can go to a property, doesn't matter where it is, and just start digging. Before we can even touch a piece of property, after we have a lease or even if we bought it, we have to post a bond with the Pennsylvania DEP. And this is very important because it really shows just the amount of efforts that the state and companies today take to ensure that the landscape is put back to its original contour. Because everybody knows, is probably familiar with the remnants of strip mining in Pennsylvania, right? I don't need to tell everybody here. I'm sure everybody's grown up and walked in the woods or played in the strip-ins, as we like to say. You're familiar with mine shafts. You're familiar with big holes or acid mine drainage. These are all the things the DEP wants to prevent. So if I design a pit, for example, and say on this particular pit, I say that the maximum crater that we're going to create to dig this coal is going to be a 3 million cubic yard void. And that 3 million cubic yards needs to get multiplied by the bond rate for 1 cubic yard, which currently is about $2.50. So, and the reason for that is because this is done so if the company goes forfeit, the state now has a bond posted that they can hire a subcontractor to come in and say, you got to fill this pit in to reclaim the land because the company just went bankrupt. So for example, a 3 million cubic yard pit is going to cost the company $9 million up front. $9 million before you even started excavating or developing a profit. Additionally, mining today, this is actually a little bit incorrect. DEP had a lot of people within our Pottsville district mining office have retired or they have a major shortage currently. And this just happened within the last year of reviewers down at DEP. It used to be about 1 year to get approved to mine. It's up to 18 months now. So 18 months in advance, we need to know, we need to start the permitting process. And part of the permitting process, aside from posting the bond, we have to have environmental groups come in at different times of the year to look for different plant species, different aquatic life. They even will look for, the little green lizards that are rare. So that they do all this to make sure that we're not going to go into an area and disturb any kind of an endangered habitat. Bats are extremely protected in Pennsylvania. It's actually illegal to kill a bat. You can't blast within the winter months, like all of our surface mines. There's no blasting. If we have a known bat hiberniculum nearby, they will restrict us from blasting because they don't want to wake the bats. And then they come, when they wake up and they fly around the wintertime, then they're awake and that's not good for them and they end up dying. But so we have, there's all kind of little triggers like that are put into really regulating a mining company so that they do things right. So once you get through this 18-month process, which is a lot of paperwork, now you move into, if you get the okay And it's just like with anything with the government, right? It's not just like you fill out these forms and then you submit it and you get an okay. It's months and months and months, conversations back and forth, modifications to plans. It's just how it works. But when you finally get the okay to go in and mine, and the state says you're going to do everything safe, it looks good. The first step of the mining operation, when we move the equipment on site, is for us, we do what's called pre-stripping. So pre-stripping, this is something that's also a little bit different for open pit mining. So back in the 50s, 60s, they used big drag lines. How many here are familiar with big drag lines? You're all, okay, cool. So the biggest difference between the way we mine and the way it was mined a long time ago, drag lines are limited on where they can place their spoil. So the machine has maybe a 200-foot boom. It could dig 200 feet, but it could only swing and cast that material so far. So when they're digging to extract the coal, they're digging the clay, the rock, everything, and just throwing it on a pile. We like and we prefer truck and shovel, or excavators and small trucks, because you could be so much more selective on where you place dirt, where you store it. So when we go in, the first step of the business is taking all the clay off, which is shown in this picture. We're digging all the topsoil off down to expose the hard base rock. That clay gets stockpiled on an area of property that we've identified to then later use that clay to reclaim after we've excavated and extracted the coal. By which, when you dump spoil like all that clay, and even though you tell DEP, look, we're putting all that clay over there in that pile, and we're going to use it to plant trees and cap everything when we're done mining, they're going to say, okay, fine. Well, how many yards did you put in that pile? And you'll say, well, there's 1 million yards there. And they're going to say, okay, well, where's $5 million? Because you have to now bond that material, because that material is placed above what they call approximate original grade. So they want everything put back to normal, and there's no way around not putting up money when you go to mine. So now that we get down to now we take the clay off, we're down to the hard rock. This is where we get into the drilling and blasting. So this is also extremely expensive. So for example, a 20,000 cubic yard shot, that's going to average about $35,000 today. But if you look at how many cubic yards we move on an annual basis per mine, 2 to 5 million cubic yards. If you have 20,000 yards in a blast, you're anywhere from $3 to $7.5 million we got to fork out and sometimes it's before we get any revenue, because a lot of the times when we're mining, the coal's all, as you would imagine, it's at the bottom. So you got to move all that rock before you get down to payday. Coal extraction. So another benefit for us using small hydraulic excavators gives you the ability to really clean that coal. You didn't really have this ability too much with big drag lines because, again, big machines, big giant buckets. Little small excavators like you see around on construction sites, or even they can get in there and peel all that slate off. They can pull the timbers out. We run into a lot of timbers. We don't find too many other cool artifacts, although occasionally we'll find like old mine car wheels or something left underground from 100 years ago. So on average, this is the mammoth coal seams shown in this picture that this excavator is digging. This guy here is standing next to the primrose seam, which is that's about 6 foot, 7 foot of coal there. Most of these coal seams contain about 15 to 20% inherent waste, which we call the slate divider in the seam. So now to take a look at a couple of our sites. This is our Stockton operation, which is outside of Hazleton. This site started in 2000, and we've been actively mining it since. This is a view looking west. Hazleton would be right out here. It's really hard to see. You can kind of see the city line. This is the foreman standing right here. kind of give you an idea just the size. This pit's 440 feet deep. This is a cross section right here. I love this because it's one of the very few pits we have where, because we're mining within the syncline where all that coal lays, you can really see all the different seams. And then when you overlay a cross section of the actual mine, again, cross sections like if you took a knife and cut the ground, you can see like the coal seams follow the exact same layout as the cross sections that were drawn 100 years ago. Just really always amazed me at how accurate these miners were. This is our Spring Mountain operation. This job we currently have idled. We're going to be returning to this pit in 2029. This particular job here, we completed this pit in 2000, just last year actually, beginning of last year. We took 1.5 million tons out of this pit. You can see one of the engineered roads that we have to get down into the bottom. Again, this is an example of just like the design work that goes into a mine like this. This is a cross section showing the syncline that we extracted the mammoth in. You can see how it's almost like a canoe. This is looking up. I like to call it the canoe because it's just a really narrow syncline. But again, safety. This is what Emershaw DEP wants to see, is how are you going to get guys all the way down the bottom of this hole safely? So here's an example of one of the big road networks that we constructed. After we take all the coal out, this is the reclamation part. So now it's time to start putting the land back the way it was. And in most cases, I will say, in better shape than it was before we went in. So, interesting thing, pretty much all the properties that we mine on, and any coal property around here, it could be all the way up by Carbondale, Archbald, or down by Hazleton. All these properties were strip mined, and all the coal outcrops were taken out by big drag lines and steam shovels 50, 100 years ago. Strip mining actually started as far back as 1874. And many of these properties, again, going back to what we discussed earlier, you all know, they're littered with open holes, shafts, holes, and everything. Well, one of the things that a lot of people don't know is for those particular properties to become useful today, whether it be for housing or industrial developments, that is all taxpayer expense to go in and physically reclaim that land, put it back to its original shape. How many of you in here have heard of BAMR, Bureau of Abandoned Mines? Okay, got a couple, cool. So Bureau of Abandoned Mines, and you might see sometimes they're in the news, they receive federal grants from the federal government. Every year they're gifted $25-50 million. They have to spend it, otherwise the money gets pulled back to the government. So you might see in the newspaper occasionally, mine reclamation project going on. That's federal money that's being used to reclaim those sites. Where does it come from? It's coming from the tax, it's coming from you. When we go into a site, it's our money that's going to reclaim the land and put it back to its original contour. We won a couple awards over the few years I worked for the company. We relocated 2 wetlands, so moving a wetland, that's another permitting thing. A lot of times you might have to, we call it move a wetland because it's in the way of coal. That's a whole permitting process there. We've gone in and have to excavate all the different types of swamp life and cattails. You have to physically move all of that stuff, especially if there's any kind of we've actually had to move snapping turtles and pick them up and move them to the new location. So it's really come a long way as far as just going in and pretty much ripping up the land to try and do it the right way. Hang on, Tom. This is a map. I like showing this. So this is an overview, 1996, before we started mining at Stockton. This is a satellite image. Look at all these. These are all mine holes, just strippings, spoil banks, tunnels. everything that's just left over from when they went in here before mine reclamation laws were put into effect in the 70s. This is the site in 2016. So our active pit is right here. You can see on the eastern end of the property, look, everything's been graded, it's been seeded, it's brought back to its original shape. A question I get a lot, so now we've done all the mining, right? We've taken the coal out. I'm sure a lot of people want to know, where does it go? That's a big topic today. Everybody wants to know, where's all this anthracite going? So an interesting fact, about 70% of all United States manufactured steel today is actually made from recycled steel called scrap. What they do is they'll take scrap metal at your scrap yards, they melt it down. When you melt down steel and you turn it into its molten form, every time you superheat or take steel from its hard phase, take it into molten form, it constantly will lose its strength. The only way to strengthen it is increasing its carbon content. That is what anthracite today is. Probably 75% of the market for it is for its chemical compound, which is the carbon content within the coal. Why it's so predominant in Pennsylvania is because we have, if you look at other countries like Russia, Ukraine, which have huge anthracite reserves, their carbon contents are also slightly different. They also have different regulations, which allows them to mine cheaper or less caring about safety in a lot of those countries. Some of you know what I mean. And that is how they were able to ship so much coal. Same with like in Asia. They can ship so much because they have different regulations on the environment, on the safety of the workers than we do in America here. When the Russia-Ukraine war started, the ban on all Russian, including Ukrainian coal, threw the price of American anthracite from as low as $120 a ton to over $285 a ton currently. So that huge boom has been great for the business here in Northeast PA, and it's really given the industry a boost to go to all these customers and want to market more Pennsylvania or American coal rather than foreign coal. So getting back to the steel requirements, so how anthracite is used to strengthen steel. When the steel's in its molten form, there's nozzles in the blast furnaces that come in and they spray very fine anthracite, which is called, it's a barley size. It's a very fine particle. I always keep forgetting to put a slide in this presentation that kind of shows those different coal sizes, because when the coal goes into the preparation plants, or we still call them breakers. Fun fact, anyone want to know where the term breaker came from? Come on.
Sure.
Right, that's it, right. So it's funny because we still call them that today. Because they used to have these big metal wheels with spikes on them. They were called rolls. And the big chunks of coal would fall into the steel rolls and it would be broken. So that's how the term breaker came about. Anyway, so these nozzles in the blast furnace come in and they spray this fine anthracite. The carbon liquefies, it drips out of the coal, burns out of the coal, and that's how you get your high strength steels like titanium. 88% of all of our coal goes on rail shipments. We're not by any means one of the largest producers of anthracite, but for in 2023 we marketed 360,000 tons, and we have a exclusive contract with Quebec Iron and Titanium, which is where they use most of this anthracite for making titanium steel. Other fun things that anthracite's used for that some of you may or may not know, I always thought this was kind of cool. So it's used in the manufacture of rubber, plastic, glass. It's actually used to make a pigment for white paint. The sugar industry uses anthracite. Amalgamated Sugar out of Idaho purchases on average 20,000 tons or better annually of stove-size anthracite, which is about this big. They use that because of its extreme. One thing anthracite is good about, all probably know this, it gives off heat. And they need that heat at the sugar mills to basically bake the the sugar beets to make them pop. Water filtration is also another industry that uses anthracite because of its carbon content. It's technically a water purifier. One misconception about the coal industry around here, or anthracite, is that a lot of people tend to say, oh yeah, coal, you get all that acid mine drainage, that yellow boy and all that. You may have not known it, but that has nothing to do with the coal itself. The coal is a natural cleanser. It's 95% carbon, right? Carbon is used to filter things. The acid mine drainage that you see at all these outfalls, interestingly, that comes from the rock strata above the coal. In the rock around here, we have everything from manganese, aluminum, iron oxide, and that's what really gives that mine water either that bluish, if it's really bright blue, that's usually a lot of aluminum in the water. If it's that orange, that means that there's been a lot of iron that's settled out of it. So interesting thing, it's really not the coal that's dirty, it's the rock. But the water filtration industry uses a lot of anthracite. I did a class trip in 2012 down to Peru. Went with my class trip. We did to look at a big surface gold mine, and here you want to talk about really nasty extraction processes. So whenever they're mining heavy metals, copper, gold, silver, they use a process called leaching. And in the leaching process, because the metals are all pretty much embedded in the rock, the way they extract them is by using cyanide. And they dump the cyanide into these giant vats and then pump it through the slurry to actually separate out the gold, the copper, all them precious metals. But then that water needs to be cleaned. Here I am all the way down in Peru, thousands of miles away from home, and there were these giant carbon filter units in this processing plant, and they were stamped Jetto Coal Company, Hazleton, PA. So it's kind of cool just how far anthracite goes and what it's used for, and it's always amazed me really how the industry is all interconnected. With that, going to open the floor to some Q&A.
When I'm out in Pittston, all these coal train cars, are they yours?
Oh, I wouldn't know that.
There's just miles of trains full of coal.
I think out by Pittsburgh, I think you would have a lot of bituminous or soft coal out there because they still mine a ton of soft coal out in the western part. Yeah, Pennsylvania is still actually one of the leading. They might be like the third or fourth coal producer in the country. The first, I believe, is I think it's either Illinois or West Virginia.
Well, where does your coal go?
Ours goes primarily to, a lot of it goes to Canada, Quebec Iron, Titanium. We have other steel mills that purchase it in the U.S. China, unfortunately, is a big buyer of American anthracite. So,
Yeah, when you drill down, do you have any problem like underground water reservoirs or maybe gas pockets that you might hit?
We've never hit, the only water that we've ever encountered is always what we call the mine pool. And the mine pool is only there because when they deep mine the coal, they left all these void spaces underground, and that's just become a natural, it's just a natural cavity for the water to fill up in. And the reason it's held there, it's actually more like trapped water because behind the coal is solid rock. So think of it as like a bucket underground that just the water has nowhere to go. It's just held there.
Could fill up your pit on you. I mean, what?
Well, we do. A lot of times we do have to move water.
Yeah.
Yeah. A lot of times we do have to pump and handle
Are you
water.
concerned about Centralia? The fire that's been going on there for like.
You know, the Centralia topic is pretty interesting. So, if you read into that one, that's
for like 50 years, right?
When that fire started, how about the reason it started? And I don't know if some of you know this or not. Some of you are not, and they know what I'm probably going to say. Exactly. It was a trash fire that started. And when they went to first put that fire out, unfortunately, I hate to be the one to say it, but when you work with federal agencies today, everything is slow paced. Nobody moves quickly. They could have put that fire out the first time had they actually went in there quickly and excavate. The only way you'll put a mine fire out is to dig them out. I didn't mention, but in our Jeansville operation that we have, we were in the news a few years ago for extinguishing a burning mine fire outside the town of Jeansville. That fire was started in the 70s by the actually burning of tires. The fire department came in, they just lit all tires on fire, caught the mammoth seam. It was burning since, I think we put it out like 2016 or 17. But any other questions? Okay, we got a bunch. Go ahead.
Isn't the mine pool level controlled by Tunnel X and Jetto Tunnel?
In Hazleton it is. Yeah.
I'm sorry, in Hazleton.
Yeah, it's all, the Jetto tunnel system is pretty much where we say everything above that is dry or mineable, everything below that is submerged. Yeah. And up here you have numerous different discharges and tunnel systems.
If we're having a Knox mine disaster, will they still be hitting coal out here?
You know, that's a very good question, and I think the answer is, I think it's no, because so in the 1950s, even if you didn't have Knox, by 1952 you had 39 coal collieries that had shut down. That had idled, and that's everything from north all the way down south, 39 total. That idled 5,200 men, and then by 1950, it was either 50, it was 1953, another 13 collieries shut down. That idled another I think 3,000 men. So you had all these guys, they were already starting to slow down, and you were getting the more frequent layoffs. I've heard it from a lot of people. You know, even my grandfather would tell me the stories of how you'd wake up in the morning and you'd listen to the radio to see who was running. And in the 50s, they were all very sporadic when they would run. The collieries back in the 50s were starting to get out of it. If you didn't have Knox, most of them companies would have just closed the doors, shut the pumps off, and just let everything flood, which is still actually still pretty much custom even today. When a mine is done, they just let them flood.
So I finally said you can walk from Pittston to Plymouth underneath the whole valley.
I believe that. Yeah, it's all.
You can come out in Plymouth as far as
Yeah. I don't think there were a whole lot of barrier pillars that were left very intact, unfortunately. Go ahead.
I got a question.
Go ahead.
When you said in the beginning, when you're gonna start, you have to put up like a $9 million bond so you can, to prove you don't just like run out and don't reclaim the land.
Sure.
So now you're gonna do it the right way. Do they give you the $9 million back to you?
You do get it back after you've done all the reclamation. So the fun thing is, right, so say the mine site is going to run for 5 years. That $9 million is sitting in an escrow account for 5, maybe 10 years, and you'll see it back after then, but meanwhile that money's they just hold on to it.
Doing nothing for you?
No, not really. Yeah, about it.
Yeah.
And how do you figure out how much a ton will cost when you're digging like that? How do you gauge?
That's pretty much all determined by the financials of the company. It's all based on the insurance for the workers, the cost of fuel, the cost of electricity. All of that kind of funnels into what is the operational cost to mine a ton of coal. I mentioned this last week or last Saturday in a presentation I gave. Does anybody know how a coal company makes more money? Or you actually mine more coal? Because if you think about it, when you run a business, you have your fixed costs that are never going to change. You're going to have, as I said, X amount for insurance, this and that, and every month you're paying that. If you're mining a very low amount and marketing a low amount, you're losing money. the more coal you can produce, with those costs staying the same, you can market and stay afloat. Go ahead.
What makes the carbon, percentage of carbon in the coal different from Hazelton and up here? How?
You know, it's a lot of just the geologic formation. I didn't really get to finish that. I'm not sure the exact carbon percentage up in the northern field, but I do know by the time you get all the way south down by like Trevorton, Shamokin, that's turning into more of a semi-anthracite. It's actually almost like dirt. You can kind of crumble it. The carbon's probably in the very low 80s, maybe super high 70s. It's just the geology, the time period when the swamps formed, you know, when how the continents probably collided in certain areas has a lot to do with it.
How long can a vein of coal run?
Miles. So the basins are measured by east to west. They run east to west, and the crops always start on the north, or and end at the south. But the basins run east to west, or northeast to southeast, depending if you want to be correct more. But they could run for miles.
You actually drill for miles?
No, so we only drill over the area we're looking.
How wide it is?
No, we only drill over the area we're looking just to specifically mine.
Okay, just so, because you know, from experience, I guess, that a vein usually goes miles and
Yeah.
I don't know how long, how wide it would be.
Well, like for example, the Hazelton Basin, I think is maybe 10 miles, 12 miles in length from one end to the other.
How wide they are.
That varies. So, I mean, anthracite, if you were to look at it, I mean, it's all, you know, it's doing this. I mean, I've seen it do everything from make 90-degree turns to it's very irregular. Nothing is consistent. With the drilling, though, you do have to be careful.
It's the thickness that really makes it productive or not.
It really is. And the quality of the seam, too. You know, I mean, you don't want to mine a seam that's very thin if it's going to just cost too much more, or if it's really low quality.
Talk about I don't know if that people actually understand in this room, quality of the coal, what BTUs mean and what ash content means. And I think the Mammoth vein is superior in all those qualities. I know we've been dealing with it for 40 years. We've been burning it ourselves in our own furnaces, and there's no heat like the coal from Hazelton, which is the Mammoth vein.
Yeah, the thing with the Mammoth, and I know the Wharton is superior quality coal. They were the first two that were mined because they knew it was the best quality. And actually, in the 1800s, when they first mined this coal, it's interesting. A lot of it was marketed based on how it looked. So
It's
if
like
it was
round.
lustful, that was a great marketing technique. And you know, then you transition into the painting of coal. Some of you are probably familiar with that. A lot of the collieries painted. Huber and Ashley painted it blue. Reading Anthracite painted their coal red. They're down in Pottsville. I think there was another two. I think Susquehanna painted it, or there was another. One of them painted it gold.
Hudson was silver.
I didn't know that. Okay. So,
The,
Yeah.
Wasn't real paper, it was like powder.
back in the 50s, mine here, that was mostly for heating, right? For home heating.
I don't know
I
what.
had no idea that they used it for filters and whatnot.
There were export markets back in the 50s. They did export. I mean, most of the coal that was mined, if you look at a lot of those big breakers, they all had, you'll see a ton of rail cars. They did have export markets, but a lot of those were dying off. It wasn't until I want to say probably in the 2000s when you really started to see this resurgence of anthracite being mined for more of its chemical compound. There's even been talk, I know my old boss was actually in contact with BMW. They were looking to build and I think they still are looking to build a carbon fiber frame vehicle. And they were interested in using anthracite specifically for that. Yeah, it's interesting uses what we've determined for. Go
The
ahead.
Air Force uses that in their planes, carbon fiber.
That's interesting.
They're not made out of aluminum, they're made out of carbon fiber.
Yeah, okay, cool. Yeah, interesting. Any others? We got, go ahead.
It's sort of off the subject of coal, but how about lithium? I mean, lithium is a big thing these days. Are there any lithium reserves in Pennsylvania, or do you ever come across that in the coal mining process?
I don't know very much about. I know, top of my head, I don't believe is any lithium reserves in Pennsylvania. The problem that you have with lithium, a lot of people don't know this because when they push batteries, it sounds great. Lithium is, I mean, I have plenty of LED lights and know just how great a lithium battery is. But what people don't know is how difficult it is. It's almost impossible to put out a lithium battery fire. You can't use water. They just do not extinguish. They just burn ridiculously hot.
Yeah, and if they get salt water, they explode sometimes.
Yeah. Yeah.
It's like magnesium,
Yeah, it's a very, very nasty process.
Class C fire.
Can you tell us about the precious metals they're finding in the rock banks, in the spoil banks?
Years ago, and this kind of, I think this died off a little bit, but a few years ago, this was a big thing, and there was a couple government grants that went out to a couple coal companies. I know Blashock Anthracite got one. It was like for $1 million or $2 million. They were doing core testing in all the rock strata surrounding the coal seams to look for rare earth elements. Rare earth elements, I know enough about this to be dangerous, but they're specific metals that are extremely rare, and they're used for like in your cell phone. They sell for a ridiculous high dollar value of $800, $1,200 an ounce. They did find some of these metals, one of them scandium. They did find some of these in the slate by the coal. So we do have these metals here in Pennsylvania. The problem is they're in such minimal quantities, that trying to mine it is just gonna, every article I've read about it, it's become economically impossible to mine because there's so little of it, is what they found.
Jeansville, was there some found in Jeansville?
I don't know if they found some in Jeansville, but I know they found some over in Jetto, I think. You know.
That sounds kind of like panning for gold in Pennsylvania.
Yeah.
A lot of pyrite,
Yeah, it was, I remember a few years ago, a lot of people were engaged in doing core sampling and looking to just see what's in the rock, and you know, they were getting grants to do that.
What is the reason you choose rotary drilling as opposed to core drilling? Is it the speed, the economy?
Rotary drilling is substantially cheaper. It's quicker. Core drilling is more expensive, just because you're using diamond drilling. Right. Is essentially what it is. I actually prefer coring. It's just more expensive way of doing testing. The only benefit a core would give, if we're looking to mine something like the Mammoth coal seam, we know the qualities of that. That's almost always consistent. But if we were gonna go mine a seam that we've never mined before, like this Gamma or Buck, that would be a situation where it would be great to take a core sample, just so that way you can measure out the slate, see the quality, the carbon content. And there's more that goes into the quality of the anthracite rather than just, I know I talk a lot about the carbon, but I mean, these guys in the chemical labs are looking, and customers too are looking at phosphorus, nitrogen. I'm not a chemist, I have no idea what some of those how they impact it, but I know they do. Volatile matter is another big one. So volatile matter, that's basically any also it can be called earthly compounds within the coal that burns off. And believe it or not, if anthracite has too much volatile matter and it burns too quickly, that's actually bad because you just burned off all the carbon content within the coal. You want it to burn slow. So that's another thing. Like down south, if you go down by Shamokin, they have very high vols. We have very minimal, and high vols is like, I think you're upwards of like 200 or something, but like we're in the 7 vol, 5 vol around Hazleton. Go ahead.
Do you run into mine gas much?
You know, someone else asked about, I think you might have asked about gases, and I forgot to answer that. So we actually did hit gas one time, first time this ever happened, last summer. We were on our Jetto site, our mine site, we were drilling to the basin of the Mammoth Seam, and we drilled our first blast pattern there, we fired it, and that went over well. Well, when we went back to drill the second shot next to it, to drill to the top of coal, so our one driller, Petey, nicest guy you'd ever meet, but I don't think he did the smartest thing. He said, oh, I could smell something. And what does he do? He goes outside the drill and puts his head right over the drill hole, and here it was CO2 that was coming up the hole. What we think happened was when we fired the first blast, a lot of the gases went back and vented back inside and were trapped in the old mine workings. So when we drilled the new shot, now you created a chimney. So he had to get rushed to the hospital. I mean, his eyes were big like this, and he's like, well, I just wanted to make sure I was what it smelled like. And it's like, geez,
No methane? No.
Carbon monoxide.
Carbon monoxide, yeah, we get that one. Methane, we don't really get methane very often. Although occasionally in the past we have had some methane ignitions as we're mining. I know in the evening on our second shift that we run 2 shifts, like 16, 20 hours a day. They actually, as they were digging the coal the one night, they hit an area where there must have been a pocket of methane, and there was a pocket of just like a flame shot out. So you do get those things. They're not extremely common, but they do happen.
I have a question about all the old calm piles that we used to have around here. And I understand that as time went on, technology got to the point where you were able to reuse some of that stuff. Do you know what the process, like, how did that, because they all disappeared over time.
The coal banks, the big thing with those, and it came about probably in the 1970s, was cogeneration fuel. The 60s or 70s, actually I think it was more in the 70s, was cogen fuel. And that basically is using, they built a lot of power plants. I don't think there's any up here, but there's a bunch of them, or there was a bunch of them down south by like Tamaqua, going down by like Higgins on 81. Cogen plants are designed to burn very low BTU fuel. It could be practically slate, which is what's in the coal banks. So they would load up all that slate, take it to the cogen power plants. They'd burn it to spin a turbine, either steam or a gas turbine, in order to generate electricity. The market for cogen fuel's kind of been diminishing, so it's just natural gas really put a big big stop on that, because cogen, when a lot of these companies would remove the banks, which I've always been for, because they are an eyesore, right? But the problem is, in their heyday, I think you got maybe $10 to $15 per ton for that waste rock, and that's assuming that bank has, because they do look at how much coal is in it, if it's going to burn right. Well, now, I mean, you might be under like $5. So there's not a whole big market. It's hard to make money, which is why that market's kind of down.
But it should change the landscape around here a lot.
Oh, for sure, yeah.
But in a good way.
In fact, they sent it to Korea.
What's that?
That slate was all sent to Korea because they have no EPA over there.
I didn't know that they interesting.
All went overseas,
Yeah, well, that's good. Let's say to burn around
That's
here.
where the Swarville is coming down. They're taking that one in the back part.
Yeah. See that one there, because that was what from the Harry E. That was a later coal bank, so it was.
There's a lot of silt in that.
Well, I always heard it was more rock than coal in there.
No, well, sections, different sections. Depends where the water settled. And you know, where the water settled, that's where the silt was.
Okay.
Some of it drained off and went into the river, and went down into the creeks, and it was a slower pace, so it took longer for it to get rid of it.
Interesting.
Yeah.
Okay. Any other questions
We
we
took
got?
our
Ryan?
coal there, so that's
Yeah,
why.
Yeah, go ahead.
This is one of the only areas in maybe the entire world where we have anthracite coal. Are there any others? I don't.
There, that's if you ever hear that, that's kind of a false statement. There's anthracite in Canada. There's anthracite in Ukraine, Russia. China has anthracite. Wales has the England. That's actually. If you wonder where all the where the melting pot started from around here, it's because when they discovered coal here, the first place. So not to get off on that tangent, but it's kind of interesting, right? Farmers and the settlers pretty much discovered the coal, and every region might have a local that they say that history can trace and say this person in the Wyoming Valley discovered coal, or down in Tamaqua. But realistically, when you're back in the 1700s, 1800s, it's hard. Like, the history's so vague. Bottom line is, the settlers that were here in the beginning, they worked the land, they hunted the land, they found the coal, and it was capitalists that came in, most of which came from Philadelphia, New York, that began to develop the coal reserves here.
That's how we heated our house when we were growing up.
Yeah.
We had a coal furnace, yeah.
I'm very familiar with that. I had to take the ashes out every day.
I'm a big bucket, so I had to take ashes out when I was a kid.
Were they heavy or no?
We all did.
When I was a kid, they were real.
Yeah, the rice coal, that's still very popular. Yeah.
We haven't had any mine societies here, because the river actually was holding everything up.
Yes. Yeah, the river, the whole Wyoming Valley is pretty much held up by hydraulic pressure.
So you own the property, because we haven't had mine societies in a long time. So that water is actually holding up the valley.
Yes, essentially yes. Well, you'd have to pretty much shut the river off, I think, for that to happen.
That's what I'm seeing, the reserves at mine societies.
Yeah, I saw that. I saw that one.
All that acid mine water came out, the red stuff. So that's all just the rock.
Yeah, that's anytime that water doesn't aerate, and to get rid of the acid mine drainage, usually you need to aerate the water. So if that mine water is moving at a pretty consistent rate, if it could get air to it, you don't see a whole lot of solids. It's when it's in a stagnant state, and once it turns orange, that's it. But if you see it crystal clear, and it could be meaning it's very super acidic, like have a high pH of, maybe like.
You see it in 40-foot, the plains you can look over, and it comes out through the woods there, all that acid mine, it's all orange coming out.
Yeah.
Now, the only part that's not frozen in the river is over there where the acid mine is.
Yeah, that's interesting.
I used to get a company from New Jersey. They came about 5 or 6 times a year, and they would take 5-gallon pails of yellow boy, and they made dye out of it. They were making a factory, and they were going to make.
I heard something about that they were looking at trying to use that for something again, for pigment or something.
Yeah, pigment. They were going to put it in paint for pigment.
I could see that become something. Yeah, interesting. Go ahead.
With these modern mining operations, like how many people do you employ then actually mining?
We're at about 180, 85 workers right now.
Does it vary on like what area you're working in as to how many people you have employed?
Well, everybody all of our operations are right around Hazleton, so we pretty much, we get people that drive from as far as up here in the Wilkes-Barre region to go south. I used to do it on a day. I used to live in Kingston, actually more 40 Fort, but the drive was just got to be really horrendous. But we do have people that come from up like in the Pottsville region too, and try to commute. So I don't know for sure. Like I don't think I would say that everybody that we employ is just from around the Hazleton area, but no.
What's the college degree you have? Like, you're an employee, what did they study in order to get into mining?
There's a couple that you could go for. I mean, I chose mine engineering.
What school?
Penn State. I guess I didn't mention that. Yeah. There's also there used to be a mining technology degree, which was like a 2-year, almost like an associate's program. A lot of people that I work with went for that back in the 80s, and that's how they got experience with like mineral processing and stuff like that.
So your new employee's a Pittston graduate from mining?
Oh, the new guy actually, he came from the so he's from up by Rochester. He went to the University of Alaska. And so we managed to pull him in. He seems to like the being closer to home, to the commute. I know that all too well. My first job out of college was working in Minnesota. I did almost a year up there, and I said they can keep these cold winters. I mean and it's like -30 up there for at least 6 months out of the year. You know, it definitely wasn't for me. And where he worked, when he worked, he actually interned at a mine in Alaska, and it's almost up by the equator, where they literally get sunlight for it's only like a month or two, and the rest of the year it's just dark. What's that?
I was stationed
Oh, really?
at Fairbanks. And we used to go-
That's where he went, University of Fairbanks.
And I had a motorcycle, used to go in the woods and find like old mining. I don't know if they're going for gold.
I think it's gold that they take up. Yeah, it's a lot of gold up there. Yeah, that's interesting.
Yeah, it's
Huh?
gold.
Yeah, I don't know if I could deal with that.
There's
Go
some
ahead.
gold pockets up near Mildred and Burness up in Sullivan County. Just outside of Lopez, I don't think it's anthracite though.
Semi-anthracite.
It might be,
Right.
yeah.
And up near, outside of Towanda, there's another, the old Barclay mine that goes back to the 1800s. There's a vein there, but it flooded out and,
Really, I didn't know that.
yeah, just outside of
Interesting.
Towanda, Barclay.
Well, we have a lot of interesting minerals in Pennsylvania. Some of you, did you know we have uranium deposits? You might not have known that, but down in Jim Thorpe, there's actually a very, very small uranium layer. And in the turn of the century, they drove a couple tunnels to explore it, but the concentration of the uranium is it's another one of them rare minerals that it's so in so small quantities it never made for feasible mining. But how about, are you familiar with Lehigh Coal, the famous number 9 mine tour?
Yep.
So when those guys were all the way down on like 8th or 9th level of the mine, I've heard numerous stories that some of the miners were actually getting, this is like in the 50s or 40s, 50s, were getting sick, uranium sickness, from being exposed to those deposits. So. Go ahead.
Who's the largest anthracite producer in Pennsylvania, right?
Yeah, Reading's currently the largest. Yeah, they. Well, yeah, no, they have the largest reserves. Yeah.
How about when they test your house they put the machine in and they find uranium? They're finding that in cellars now.
Oh, they do. Yeah, we know someone, don't we, Dan, with radon in their basement. Go ahead. Deep as like surface mine or underground? The largest mine we have right now is just over 440 foot. So that's a Stockton job. But that 440 is actually to top of water level. We actually are going below water level, which would put the ultimate pit at like about 500 some feet. Any other
Where do
question?
you put the dirt? When you get it out? You save it?
The dirt goes behind, so the mine is kind of almost moves. When you excavate an area, that material goes behind you. When you take what we call another cut, that material goes to fill in the void. So the hole's constantly moving, if you will.
How did that work out in Cranberry when they brought that stuff from Delaware River and they filled that all in the end, the hazel in there?
Yeah, I don't know the whole story with that, but they brought in river sludge.
Yeah. I was wondering if it stayed there or if it solidified or what.
I don't know.
That was almost Cranberry where that was.
Interesting.
Do you do tours in the summers?
We actually do some tours. We were looking, actually I know we've kind of been in contact with I'm sure a lot of you are familiar with the underground miners. We're in the conversation phase of actually maybe doing some kind of a tour, maybe at some point this upcoming year or at some point soon. Bringing in a bunch of people to see. Yeah. Go ahead.
So the General Mine Tunnel, it's kind of a sore eye in the local community in Drumson and Cunningham. And so, and I know you kind of put back the land and for good conservation efforts. Do you ever educate like local schools and school districts on the fact that you're pulling out coal to create energy, which is a good thing, but there are some negative environmental, sores to the community. So is there any education with school districts, because according to the PADEP, we are in an environmental justice zone, which, we're 92% out of 100, 100 being the worst. It's a mapping tool that ranks 30 different criteria, economic, pollution rankings, and all these. It's a calculation. So we have some of the higher cancer rates. We have some of the higher asthma rates, respiratory rates, and I'm from that region. And the General Mine Tunnel actually goes right behind Drumson Elementary School, where I went to school. That's why this has been something where I'm actually educating local schools locally to talk about the reality of industrial work, the emissions. Why did coal go away? It created heavy emissions. So do you ever or believe you're willing to do that in the future potentially to educate young kids?
Yeah, I'm all for that. I know this upcoming year we're doing a class trip from MMI, to have their geology students come out and visit the site. Just to touch on the Jetto Tunnel subject, so fun fact about that, when we restore the abandoned mine lands, all that mine water, the majority of it all of it really is coming from the surface. When we fill in and remine and strip and reclaim that land, you're sealing off all of those void spaces. So now what we've done around Hazleton is taken and work on reclaiming 20 square miles of land where that water previously went through the ground, got contaminated, went out the Jetto Tunnel to the Susquehanna as contaminated water. We're now restoring it as clean water and sending it to the Lehigh.
Nice.
Oh, that's good.
All right.
Thank you.
Thank you.
Very
Appreciate it.
informative. I know we all learned a lot.
Well, yeah, this was fun. I'm glad. Thank you everyone for coming out.
Thank
I'll be
you,
here for a
everybody.
little bit afterward too.